Obtaining and Processing DEM Data, Part 1. In this video, we'll talk about working with DEM, or Digital Elevation Model, data. This data is often pretty exciting for people because it gives you a representation of relief for the area of interest, and there's a lot of other layers that you can derive from this information. So it's a really useful data source, and tends to be one of the more popular data sources, especially for raster data outside of the aerial photography that we've already covered. The DEM data is usually has been produced by the USGS, United States Geological Survey, like a lot of our other data has been. And it used to be available from a website that they had set up, actually the same site where we downloaded our DLG data. If you go to that site, you'll notice, which I've not done here, but just for reference, you would notice that they have DEM data still, but it's only at the 1 to, I think, either 1 to 250,000 scale. So the 1 to 24,000 scale that we tend to work with a lot in our class has been taken off of their server. And what they've done is opted to make that available through other vendors that are out there. And luckily for us, one of their more popular vendors is the GIS Data Depot, which is the site that we've already discussed for a lot of other data. One of the drawbacks, though, I guess, if there is a drawback to it, is that they do require you to set up an account with them. You don't have to give them any money, but you do have to set up an account, and they'll collect a little bit of information about you, I think, such as a name and address and things like that. They don't ask for a credit card, though, so you don't have to put that on there if you don't want to. If you want to get to their premium data, which would include the aerial photography and things like that, you do have to pay them money for that. So, but we've discussed other sites, and I've tried to use examples in this class to demonstrate where you can obtain a lot of that other data for free. The DEM data can be a little harder to find, partially because a lot of it is being replaced now with another type of relief modeling kind of data called the NED, or National Elevation Data Set. The DEM, the reason I like to still use DEMs is because, in my opinion, the resolution comes out a lot better than a lot of the NED data that I've seen. And also it's available in the quad format, which is sort of consistent with the other types of data in terms of their format that we've looked at. A lot of this data is becoming more available in these sources called seamless data sources, where you can download them somewhat in bulk or in larger image areas. But I like to use for this class, and especially in your initial training, I think it's important to get used to the quad format, like I've mentioned before, because a lot of the other data actually is derived from that format, and tends to be mosaics and things like that produced from that format anyway. So this makes it a little easier to understand, I think, and to use references such as our quad index that you've already seen to locate the names of these references so that you can find them more easily. So what I'm going to do for our example, I'm going to assume that you have an account set up on the Data Depot. And what I'll also do is, in case you don't have one yet, or if you don't, really against creating one, then I'm going to make the two quads that we're going to use for this demonstration available for download from our website. Understand they'll be rather large, though, so it may take you a little while to download them, but shouldn't be any longer than it does from the other data sources. But there again, if you have a chance, it'd be nice to create an account with them so that you can get to this data. It is free once you set up the account, and it will give you good practice for locating data from this source. So I'll proceed now. I'm already on the Data Depot site, and I've already logged in. And you log in up here in this area. You can see I'm logged in because it's giving me the option to log out now. So I've already logged in, and I'll use their handy little map here they've set up to go to the area of interest. And for this example, what I want to do is just build on our previous example. If you saw the earlier video, in the Yosemite region. So we obtained some vector data previously for that area, and now let's obtain some of the DEMs for that area, that same area. And this would be nice in case later on your own you want to combine them into the project with some of your other vector data. So what I'll do is select California, and it will pop up a separate window here. It's a little aggravating because you tend to get multiple windows open here if you're not careful. And I'll go into the countywide data for California. And the county that I've already predetermined a lot of this, and by now you should be used to doing this on your own. You probably remember this from the previous exercise, but be sure to practice with building just some simple projects using layers that you already have available, like the county and state and quad index and so forth. And what I like to do, just as a side note, is I'll build a little template map of my own, call it like a reference map or something that I can just pop open on the fly and determine the quad names or other information that I need to download real easily, so I don't have to build that every time. But in this case, we'll assume a few things for the sake of time. So we already know our county in this example is Mariposa. So I'm going to select Mariposa. And here's a listing of all the different types of data that they have available. And you'll notice the very first one in the list is the DEM, and it's at the 24K resolution, which is what we want. So let's select that. And it will take us to a listing of all the quads for DEM data that they have available in Mariposa County, California. And the two areas that we're interested in are Yosemite Falls and Half Dome, if you remember from previous exercise. So Half Dome comes first, so let's go ahead and select that one. And before I do, let me select the More Info, which shows you what metadata they happen to have available for that quad. And in this particular area here, I'm looking to see to make sure. I was thinking somewhere they showed the projection, and here's some of the information here. And a lot of times you'll see this, you know, as I pointed out elsewhere in the videos, a lot of times this metadata is somewhat mixed. For example, here we see that it's mentioning UTMs, and it's a datum of 1927. It says or 83. It can be a little troublesome, as we've looked at earlier, but for the DEM data, one of the nice things is this information tends to get built into the format of the data. It's one of the very few data sources that you do not have to actually define projections for. The projection gets set once this data is ultimately created into the GIS format. So it will take care of it for you. But just for reference, I just wanted to point out that nearly all of the cases that I've seen, the DEM data is in UTM 1927 datum. I very rarely find it in 1983 unless you're just lucky enough to find it from a source that's happened to convert it, because the USGS made it available initially in the 1927 datum, and so that tends to be what it's stored in, which may necessitate you reprojecting it later on, and we'll deal with that a little later. But just wanted to point that out, that this metadata in this particular case is mixed help. It does tell you information about the DEMs and important stuff to know about what they are and things like that. But remember your projection. If it doesn't say otherwise, assume it's UTM 1927, and as we can see here, in some cases it will tell you it's one or the other. And again, it's kind of hard to figure that out until you've processed it and go into ArcCatalog and look at it. So anyway, I would still save this type of metadata, and just to have it to turn in with my projects and such, and to have for future reference. And remember before, I think I showed you, but in case I didn't, one easy way of saving this kind of information is if you have Snagit, you can sort of snag the page. Another way is if you're using Internet Explorer, which I recommend using when you're downloading GIS data, you can go to File and Save As, and they'll let you save it as an archive type called MHT. And and the MHT data, it ends up being just one file, so it makes it very handy. So I'm going to go ahead and save this into my working folder, and I've got two subfolders that you probably don't have on mine here, and I will set up a folder for our exercise. Call it exercise 3. And those of you in the in-person class that might be listening to this, yours will probably be called exercise 5. set that up, and I'm going to make a subfolder here for DEM, and inside that I will save, and since all of my data in this case is going to be downloaded from the data depot, I don't need a subfolder for that. I'll just save this here, and I'll just call it my DEM meta data and save. And that will save me one file that can be stored for future reference there. So now let's go back to the download page, and let's go ahead and download the Half Dome DEM data. And notice they have the green icon is for the free download. If you have paid them money and want to download it a little bit faster, you can follow the gold icon. Takes you to the ultimate pipeline, as they call it. It's supposed to be a little bit faster, but in my case, I like to save the money for the other files that I have to pay for. So, and this is nice. We can see here, and something I didn't mention before, is that when the USGS initially created this data set, oops, sorry about that. I have a lot of reminders that pop up on my computer from my email program. When the USGS initially created the DEM data sets, they were available at 30-meter resolution. And that was nice because at that time we didn't have any of this kind of material. Later they went back and resampled that 30-meter data down to a 10-meter resolution, which is much better, creates a bit larger files, but still the trade-off is pretty negligible considering what you get out of it. So what I'm going to do in this case is go with the 10-meter, but while I'm here I just want to point out that if you happen to be covering a larger area where you're going to have to download a lot of these quads for some reason, then you might consider getting the 30-meter, at least initially, because it will give you a quite nice relief in the end and saves you lots of time on downloading and mosaicing and things like that. But for this example we only have 2 quads, so let's go ahead and just get the 10-meter resolution. And notice here they've got a text file, which is another metadata file. I'm going to open this one up. This one is much more helpful than what we saw back on the initial site, and was probably included with the original data. And in here you can see that it does indeed point out that we're dealing with the datum of 1927, UTM, and it tells you the zone 11. So that's handy to know, and much more useful than what we saw earlier that I was showing you. So we'll remember that for future reference. And let's go ahead and download that file while we're at it as well. So I'm going to just select that file. If I right click, I can have the option to save as, which is what I really wanted. So let's do that, and we will put that in our working folder, our exercise subfolder, and we'll store that there. And then let's download the 10-meter data. And it remembers the folder we were using, which is nice. And it's going to take just a minute to download. So I'm going to pause the video while it's downloading. And while this is downloading, just to note, I'm going to pause the video while I go ahead and process the Yosemite Falls quad as well. So I'm going to assume you know how to do that by now. So go ahead and download both of the quads. And when I say process, I meant to just say download. I'm not going to actually process it yet. I will show you that, because that's the purpose of the video. So go ahead and download the 2 files and make sure they're stored in your DEM folder, and then we'll pick back up in just a minute. Okay, we're back, and our files have downloaded. I've opened up my Windows Explorer and browsed over to the folder where I have them stored. And you can see here what I've downloaded was the initial MHT file that I demonstrated earlier. There's 2 text files, which are the metadata for the specific quads we downloaded, and then there are 2 zipped up files, one for each of the quads. Similar as is done with a lot of the other data, various codes and abbreviations and different lettering or numbering systems are used to identify these files. It can be pretty confusing. The best thing I can suggest is to be very organized with the folders that you create as you download data. For example, I could have created 2 subfolders, one with the Half Dome, somehow abbreviated to keep it 8 characters or less, and Yosemite Falls. But since I knew I was only downloading 2 files, I just went ahead and put them in this sample folder for this demonstration. but that's something to be aware of. We will rename these a little bit later, as you'll see, and that will help. But for now, we've got these two files to start with, and notice that there's a lot of dots in here. There's a lot of extensions in here. They've been zipped up in various ways. Actually, these have been double zipped, once with a TAR zip and then a G zip. Luckily, if you're running WinZip, now I'm not sure about some of the other ones like 7-zip and so forth, but WinZip will unzip those quite easily. And the way you do that, which you're going to want to do here, so let's go ahead and unzip the first one. And once you've used WinZip, if you right click on the file like I did, you'll have this handy dialog here that pops up that you can with just a couple clicks extract the files. And we have various options here, and usually I'll use the extract to here, but to keep things a little bit easier to clean up here in a few minutes, I'm going to let it create a subfolder within this one, and it gives it by default the name of the file name, which is quite long, but it's only going to be temporary for us. So let's let it use that one, and it will probably prompt us, yes, if we want to open a temporary file, go ahead and say yes. This temporary file gets deleted automatically, and it's something that WinZip uses as it's processing this unzip, and it has to do with it being double zipped. So you can see that it created a folder for us here. Let's go ahead and unzip the other one while we're doing this, and let's extract it to its own folder in this case as well. And we now have two folders, and we can open up one of them, and you can see that what it creates, I'm going to change my view to show the details, it creates a whole series of .ddf files. And these, you can just think of them as another type of SDTS type of formatting that the USGS used when it created these files. And you notice all of them are very small except for one, which you can pretty well rest assured that contains the raster information for the file. But all of these various files will get used in creating what we call a .dem file, which is what you typically think of when you're obtaining a DEM file. And that's sort of a halfway to where we need to be with it in the end. Right now we're dealing with the actual raw data files. We do have a README file in here that probably contains some other information about the metadata and so forth. But what we want to do, there's a utility that we have available that will let us process these files and creates the one.dem file for us, which gets us a big part of the way to where we need to be with processing that data. And to get that program, I have it loaded on our class website, and you can download it from there. Let me browse over to that. And where I've located this file is under our reference materials in the content page. And under reference materials, one of the drop downs you'll see is for software downloads. And the very first item is the SDTS2DEM program. And it's a very small program. You can go ahead and download that. I'm going to right click on it. Let's see, I guess I better left click on it. And you might get a couple warnings about downloading depending on which version of Internet Explorer you're running. Just select that and download the file, and it will give you the dialog where you can save it. And what I do, I typically save programs. I may have showed you this before, but I typically save them on my C drive. I create a program updates folder, and in there I'll put various files, programs I've downloaded. You see I've got GIS Tools 2009. Let's make a folder there for the SDTS2DEM, and I'm going to save that in there. Close my dialogues, and let's use Windows Explorer to browse over to that folder, and we want to unzip that program. And here we go. And let's unzip that. We'll extract to here this time. And you'll see it creates just one file. If I look at my details, you can see it's pretty small. It's only 226K. This is an old DOS-based program that was created back in the early 90s by an employee with the Bureau of Land Management. It's very handy, but it's very old. And so it runs into a DOS-based dialog once you execute that program. So what I'm going to do, that's why it's so small, and what I'm going to do is leave the original zip there, so I have the original if I ever need to go back to it. And what I like to do, because this is a DOS-based program, is I'm gonna in this case cut it out of here since I've got the original, and I'm going to move back over to one of the folders where I unzipped the data into earlier, and I'm going to paste it into there. And since it's so small, I'm just going to copy it again, and I'm going to paste it into the other folder as well. And by doing this, as you'll see in a moment, it lets the program run without you having to type in any type of folder names when it runs. It just makes it a lot easier to run the program. So what we'll do, let's execute the program and tell it to run. And you see how it opens up a little command dialog that's running in DOS mode. And the program actually kind of walks you through the steps to take to execute it. But I'll go over that here just as a reference. And what it asks for, if you notice on these DDF files, the first 4 letters are the same on all of them. They're actually numbers, and in this particular case it's 1106. And that's what the program's asking for to start with. So we're going to put the 1106 in there, hit enter. Now it wants to know the base output name, basically the part before the extension, what you want to call this without the .dem on it. And this one, actually, I cannot remember if it's the Half Dome or the Yosemite. So I'm going to peek at the README file here real quick and see if that will tell me which one it is here that I'm dealing with. And he wants to know which application to open it with because it doesn't have an extension tied with it. And let's see if it tells us here. Oops, it does not tell us here. So what I'm going to have to do in this case, I'm just going to execute this, and this is a perfect example of why you might want to create some subfolders with the names. I'm going to go ahead and give it one of the 2 names, and then I may have to rename it here in a minute. So it's a little roundabout way of doing it, but this happens when you're doing things live and on the fly. I'm going to go ahead and call it Half Dome, abbreviated. Half. Oops. Actually, I can spell it out all the way because it's 8 characters exactly. I'm going to give it Half Dome, and when I hit enter this time, it's going to process that file. Computers within the last 3 years were slow enough you could actually see what it did as it processed it. Now, unless you look really quickly, it will go very fast, but you will see the name in there if you look closely as it's processing, so we can see if we're going to need to rename it or not. So let's execute it, and I do see Half Dome showing up in the name. You see 10 meters. If you look quickly, you saw 10 meters there, which was your cell resolution, and I believe I saw some a zone 11 in there, and some perhaps a UTM. So that created this file here, and we got lucky. Half Dome is what we actually wanted, so we guessed right on our renaming there. So we don't actually have to rename it here. So it created the .dem file for us, and what I'm going to do is I'm going to cut this out of here and move it out to the folder before this where we had it to start with when we downloaded it. And then I'm going to go back. I want to make sure I delete the right folder. It was the 1705538, as you see the name here. And what I want to do is actually delete that subfolder that I had created earlier, because we don't need anything in there any longer. We basically needed the DDF files to process it, and then we don't need those any longer since we've got our DEM file out of there. So let's do the same thing with the Yosemite Falls. Run the program again, and the numbers here again happen to be 1106. It's the same this time. A lot of times they're not. And this is another reason why it's good to run these in separate subfolders, because they would have actually overwritten each other if we hadn't done that. So 1106, and we'll abbreviate this one YOSE, FALL, Yosemite Falls, for Yosemite Falls. Remember, it's nice to keep these 8 characters or less. And we'll run that. And we've got the DEM file. You notice the DEM files are larger than even the sum of the DDF files, which partially explains why they've created that SDTS format. It also saves some space, and when you're dealing with 54,000 quads, you can see why they might want to do that. So we'll cut the DEM out like we did before, paste it out here in the root of our DEM processing folder, And then let's delete that subfolder we had created that has the DDFs in it. Notice all of this I can get back to again. I've still got my zip file. I can recreate any of that if we have any problems and need to do so. And at this point, if you had one set up, it might be a good time to move these zip files into your archive folder, which I'm not going to actually do here, but well, I guess I can go ahead and do it since I have it set up. And I just need to create a folder for DEMs. And ideally, I'd probably create one for the quad name, but since I don't actually remember which one of the two are which, I'm just going to paste them both in here for now. So go back and right click and cut those, and we'll paste those into our archive folder. And this is just basically saving us some space. We're keeping sort of the master archive folder for all of our exercises and data that we might download, and then we've in our EXER3 we now have saved some space in our DEM folder by just having basically the two finished DEMs and a couple other files in there. The little dialog that popped up, by the way, was letting me know my session on the Momentum site was sort of wanting to time out. So let me browse over there real quick and log off of that. And then we'll move back. So we've got the DEM files here now, and now we're halfway there. We can go ahead and start up Arc Catalog. And note, in your case, you don't actually have to start Arc Catalog because, as I mentioned before, these files, when they get processed, the projection data already is included in them. So you can go straight to ArcMap with these particular files. But I wanted to just show you that they are indeed set up with the projection. So that's why I started it up. So I want to browse over to the folder. And you'll see that it recognizes that they are raster type data. And let's select one of those and go over to the metadata and spatial tab, and you'll see that it has been processed already with our projection. So we don't have to define a projection for that. Now, there would be a problem if normally you can also preview your data, but if you try to preview one of these files, you're going to probably get a black box instead of an actual data file. And there's a reason for that, and we'll look at that here in a moment. So basically, you don't have to actually open Arc Catalog to do anything with these files at this moment. I just wanted to show you that the projection information is included there. So I'm going to close that and go ahead and open ArcMap. And with the newer version, while this is opening, let me tell you that with the newer version, the 9.3 version of ArcGIS, they included, they imply that you can actually open the DEM files in the program. So what Esri has done is made it to where it implies you can read these DEM files directly into the program. There's a step you have to go through before you can do that, but just to show you, and again, this is just for demonstration because in your case you'll not want to do this, but I wanted to show you what it looks like. And if I load file in, again, it sees the files as if it's a regular data source that you can read in. It even senses that they're raster data. But if I add the file and ask about the pyramids again, I'm just going to say no in this case, I get a black box, just like you saw back in the Arc Catalog. So that's why you actually don't want to do it that way. But it's so common for people to load that, and then I get a lot of questions about why am I getting this black box. I wanted to show you about that. What you actually want to do in this case is run a tool in the toolbox. And Esri has made a tool that will convert DEM into a raster file. And even though the DEM is a raster file, it's technically not one that ESRI products will read in directly as yet. So what we want to do in this case is use one of their conversion tools, and we'll go in the to raster drop down, and one of the options you have there is a DEM to raster, and let's execute that. And here we can load the DEM file in. I'll browse over to it. Notice I've kept the 8 character or less naming structure in all of my subfolders leading up to this and in the file itself. And just in case you've wondered, you know, all semester I've talked about keeping this 8 characters. It's actually these DEM files, which and some other grid type files, which is really the reason for doing that. Some of them will work at 10 characters, but 8 characters, I've seen that pop up from time to time, and it's just easier to go ahead and set a standard of 8 characters and not confuse everybody. So this is actually getting to the part of the course where it's real critical that the 8 characters or less be used, or else you'll get some very unusual processing errors that are kind of hard to explain. So we'll select the half dome quad, and it will load that into the memory here. And then what it does, as it does with a lot of things, is it goes ahead and gives it a tentative name for you. And you'll notice the name itself violates the 8 character rule that we come up with. Let's rename that. It tends to be not a very good name anyway. And what I like to do is just give it the same name as the input file. Because once this is processed, as you can see from the little help dialog over here, it's not going to be a .dem format any longer. So the name won't override anything. And what we're going to use is we're going to let it default to the grid file format, which if we do not give it any extension, that's what it will default to. You can technically convert it into TIFF files or ERDAS Imagine files and so forth, but the grid file is important if you're going to do any future processing within the ArcMap program. So let's go ahead and we're going to rename it, and we're going to not give it an extension, so it will default into the type of raster file called a grid file, which is basically an ESRI proprietary type format. So we'll call it half dome again, if I can spell it right, without an extension. And then it asks the next dialog, do we want to use float or integer? And basically just tells you over here what that is if you look on the help side. Just go ahead this time, instead of float, which would be a decimal type format, we're going to use an integer format, and I'll explain why here in a minute. So switch that to integer, and now for your z factor, let's leave that set to 1. If you've got the help box open, it will explain a little bit about it. And basically this is an exaggeration factor, where if you're dealing with areas that's very level, like maybe the plains part of the country or out in West Tennessee or something, you might want to exaggerate it just a little bit so you get a little more relief that shows up in your quad. I like to start off with keeping it set to the default of 1, which is no exaggeration, because to me that is the more realistic option. That's actually representing the data for what it is, and I like to do that. And then if I see that I need to exaggerate it later, I can always do that later. But to keep everything simple, let's leave that set at 1 for now, and I'm sure we'll have plenty of relief anyway in the area we're dealing with. And that's all our options. Let's go ahead and execute that, and you can see what an actual DEM file looks like once it's loaded properly. And there we go. So there you can see that we don't have just the black box this time. We actually have a file there we can work with, and looks a little funny right now, but it is an actual DEM file that's been loaded and converted into a grid and loaded into the program. So while we're here, let's go ahead and load the other file that we have. We'll convert that a little more rapidly this time. Luckily it remembers the folders we use, so our dialogues work a little faster. Again, give it the same name, because it's not going to be a .dem file once it's created anyway any longer, so it won't hurt anything, and it makes it easier to keep up with them later. Switch the float to integer and say OK. It reads that file in, and notice it put it above that, so I'm going to go ahead, close my toolbox. I'm going to zoom to the extent of both of those layers, and you see a little color shading different, and